everybody. I'm going to try to do a good job of talking right into the microphone because I'm actually doing this recording in a coffee shop where there's music and there's people talking, and I've tried to find as quiet a spot as I can, but just turn your volume up if you need to. So we are going to be mostly looking at 6th grade math, lesson 5-2, but I'm starting with just a little bit of 5-1. So let's get going because we have a lot to fit in here. All right. Let's read this. After games in Lydia's basketball league, one player's family brings snacks for both teams to share. This week, Lydia's family will provide juice boxes and granola bars for 24 players. You can make a model to help you find the least number of juice and granola packs that Lydia's family should buy. And the book goes on to suggest that you use color counters, drawings, or pictures to illustrate the problem. I'm going to show you their illustration of it, but we're not going to do our problems that way. We're just going to do them mathematically. But let's read example 1. Juice comes in packs of 6 and granola bars in packs of 8. If there are 24 players, what is the least number of packs needed of juice and then of granola bars so that each player has a drink and a granola bar and there are none left over? All right, so what the book does is they do a diagram of this for you. They draw a picture of one pack of 6 juices, another pack of 6, another pack of 6, another pack of 6, and then one pack of 8 granola bars, another pack of 8, and another pack of 8. And that's how they get to 24 here for 24 players, because 6 times 4 is 24, and that's how they get to 24 granola bars, because 8 times 3 is 24. So what I want you to pick up on there is multiplication. If we knew that the juice came in packs of 6, all we had to really do was say how many times will 6 go into 24 evenly, and that's 4 packs, as you see. 1, 2, 3, 4. Sorry about the shadow of my pencil. And if the granola bars come in packs of 8, how many times does that go into 24 evenly? 1, 2, 3, because 8 times 3 is 24. So hopefully you see how that works. Now, one thing I forgot to warn you about is that this table is uneven, and so every time I lean on it, it makes it move back and forth. Let me see if I can stabilize it. That might help. Okay, let's look at the next page. What we're working on here is finding something called the least common multiple, or LCM. I'm going to draw that in my book right here so you can see it. LCM. Do you remember before Thanksgiving we were working on something different than this called the greatest common factor? The greatest common factor was what is the biggest thing in common that makes up 2 numbers. Here we're looking at the opposite of that. What's the least common multiple? When we're talking about multiples, we're talking about things that are bigger than our number. For example, the multiples of 3 are all the things that 3 will go into it. So it's 3 because it'll go into it 1 time, 6 because it'll go into it 2 times, 9, 12, 15, 18, and so on. And when we're finding the least common multiple, we're finding the multiples of 2 different numbers or more numbers, and we're finding whichever one is least or smallest that they have in common. Now, if you need to listen to that again, just go backwards a little bit in the video and let's do that. But now let's start looking at ways mathematically to find least common multiples. I'm going to introduce you, I'm going to point out the 3 different options that they give you, but we're going to stick to one for our future. So the first one they want you to find the least common multiple of 6 and 9. They go to a lot of trouble to draw a number line that goes all the way to 18, and then they jump on the number line first by 6s in one color, 6, 12, 18, and then by 9s in another color, 9, 18, and they find that the first thing they come to in common is 18. That's a lot of work. So here's the method that I would like for you to do. This time we're going to find the least common multiple of 3 different numbers, 3, 5, and 6. So the first thing we're going to do is count by 3s or find multiples of 3 on a good ways. Like we'll go a little ways and then we'll see if we have something in common with all of them, and if we don't, then we'll go further. So we're going to say 3 because 3 goes into 3, 1, and then 3 times 2 would be 6, and then 3 times 3 would be 9, 3 times 4 would be 12, 3 times 5 would be 15. So basically we're just counting by 3s. And then we do the same thing with 5 for a while, and then we do the same thing with 6 for a while, until we come to a spot where we have the first thing that we come to that's in common. As you can see, 30 is the very first number that we came to that all 3 possessed. So we would call that the least common multiple of 3, 5, and 6. Now, let's go back and do it that way and find the least common multiple of 6 and 9. So we're going to do it the way that I want you to practice it, and that means we're going to say, what are the multiples of 6, and then what are the multiples of 9? The multiples of 6 are 6, 12, 18, 24, and I'm going to stop there and see if I come up with one in common. I know that's not real easy to see with my hand in the way. And then counting by 9s, 9, 18, 27, 36. And of course, the first thing that we see that they both had was 18. So 18 is the least common multiple. Now let's go down and do another example. This is another way of finding the least common multiple, but I have always found this to be a little bit laborious. I also think that it's a little bit complicated, and I also think that right after learning factor trees and prime factorization, that this can get confusing. It's too similar and yet not similar at all, and it would be easy to combine the two without thinking. So that's why I would like for us to stay away from this one. So let's say we wanted to find the least common multiple of 8 and 12, but doing it the way that I'm teaching you to stick to. So 8, 12, you'll be able to see it better once I'm done. This is going to be 8, 16, 24, 32. Now, one thing I noticed when I wrote 24 is that I know that is actually going to be a multiple of 12, so I'm going to stop there. 12. Now I'm going to count by 12s. 12, 24, 36. What's the first one that we come to in common? It's that 24, and we can circle it like this if you would like, or circle it individually, but that is our least common multiple. Now I'd like for you to pause the video, and I would like for you to try to find the least common multiple of 12, 10, and 15. Remember, that means the smallest or least, that's why we call it least common multiple. So the smallest multiple in common, or the smallest number in common when you're multiplying these out. So you pause and do these, and I'm going to work on it right here, and then you can come back and watch. All right, I'll keep going, you pause. So it's going to be 12, 24, 36, 48, 60, 72, 84, 96. Let's see if we're going to come to one yet. 10 is going to be 10, 20, 30, 40, 50, 60, 70, and let's try our 15s. 15, 30, 45, 60. Oh, there it is. That's the one that we came to that they all had in common. So it was the least, or the smallest number that all of them had in common. All right, so now I would like for you to turn to lesson, let's see, you know what, let's go back and do a couple more of these for practice. I would like for you to pause the video and find the least common multiple of 3 and 4. And then I would like for you to find the least common multiple of 4, 5, and 8. And then I would like for you to find the least common multiple of 6 and 20. So the first one is 3 and 4. The second one is 4, 5, and 8. The third one is 6 and 20. Pause the video, find your least common multiples of each of those, and then come back and I'll give you the answer. Alright, so here are the answers, as you can see. The first one I assigned you was 3 and 4, and that least common multiple is 12. The second one was 4, 5, and 8. That least common multiple is 40. The second one was 6 and 20, and the least common multiple was 60. If you didn't get those right, you need to do them again and retry until you get them correct, okay? Alright, now let's turn to lesson 5-2. So you should be on page 198. And this is going to be using least common multiples that we just learned about so that we know how to add and subtract. Adding and subtracting with unlike denominators. So we're going to be adding and subtracting fractions using unlike denominators. And all I'm going to do now is get started on this lesson and get us moving in the right direction, and then we'll have to have a second video that finishes it up. All right, so let's read this. The Pacific Ocean covers 1/3 of the Earth's surface. The Atlantic Ocean covers 1/5 of the Earth's surface. To find the fraction of the Earth's surface that is covered by both the Atlantic and the Pacific Oceans, we are going to need to add. We're going to add 1/3, which was the Pacific Ocean, and 1/5, which was the Atlantic Ocean. Unfortunately, we call those unlike fractions because they do not have common denominators, and we cannot add fractions that do not have common denominators. So, to add or subtract unlike fractions or fractions without common denominators, we're first going to have to write them as equivalent fractions with a common denominator, and I will introduce you to what that means. So our main words here that we need to think about are, first of all, a common denominator. A common denominator means that the bottom of the fraction is the same. Let's look at an example of that. In the example, we were looking at 1/3 plus 1/5. Let me just see if I can shift a little bit so that my hand is not always in the shadow. Okay, 1/3 plus 1/5. We cannot add that because it doesn't have a common denominator. If I wanted to make a common denominator, I would use what we just learned, the least common multiple. The least being the smallest multiple or number in common that these two denominators have. So I need to find the least common multiple of 3 and 5. Well, we could do it like this, but I would like for you to start learning to do this in your head. So here are our multiples of 3. 3, 6, 9, 12, 15. And 5 is 5, 10, 15. But in my head, just thinking about what both of these numbers went into, I knew that the first thing I was going to come to in common, or the least common multiple, is going to be 15. So now let's start talking about a new word, not just least common multiple, but least common, meaning the exact same thing, denominator. So that multiple is going to become our denominator, and we're going to call it the least common denominator. So let's rewrite 1/3 plus 1/5 as equivalent fractions. That means this one will be equal to that one, and this one will be equal to that one. But instead of being 3 and 5, we're going to find the smallest number that they will both go into, or the least common denominator. Now, some of this is similar to what we were doing recently, finding equivalent fractions. This time, those equivalent fractions just happen to need a common denominator. So we found that the smallest thing that 3 and 5 both go into is 15. So I know that my new fractions are going to have 15s on the bottom. But remember, this fraction has to equal that fraction. How did I get from 3 to 15? I said 3 times 5. Whatever I did to the bottom, I must do to the top. So if I said 3 times 5 on the bottom, I've got to say 1 times 5 on the top. All right, now let's look at the second fraction. How did I get from 5 on the bottom to 15 on the bottom? I multiplied by 3. So now whatever I did to the bottom, I must do to the top, and I'm going to say 1 times 3. Now look how easy this fraction is to add. We have a common denominator. We never add it. It just tells us how many in all, but then we add our top. Now, I'm looking to see if I have enough time to show you this, and I think I do. I am not going to try to make this exact for the sake of time, but I want to show you why we don't add our denominators, okay? And this is not going to be accurate, but I'm going to say that 5/15 is 1/3. So about 1/3 of this is probably going to be about that much of this pizza. This is a pizza, by the way, okay? And about 3/15 is going to be much, much smaller than that. It's not even going to be... It's going to be 1/5 of it, and that's going to be hard. It's going to be less than 1/4, so we'll say about this much, okay? And I actually should have put that in a different place. But what I want you to see is if we want to add these two together, 5/15 plus 3/15, all we're going to do is take this shaded part over here and add it on to what was already colored. And now we have about 8/15, which is just over half of this pizza. So we didn't need to add our 15ths, we only needed to add our numerators. All right, I'm going to pause there and start another video to finish lesson 5-2.